There's a number of advances that enable these technologies. One of them is printing, and there's lots and lots of development in printing, whether that's larger beds, new materials, higher resolution, better software tools. And we're collaborating with some of the leading industry partners in that space. Material science, there's rapid development there that allows us to program these materials, new fundamental properties, new response to energy, new mechanical properties, etc. I think also there's another side, which is this programmable matter space, which is synthetic biology, material science advances, and this vision of robots without robots, this vision of soft, agile, reconfigurable, reprogrammable robots. And so all of those together allow for programmable materials. After we introduced the topic of 4D printing, we were extremely lucky that a number of companies came to us and said, this is exciting, can we do it with this industry? Can we use this material? Can we design 4D printing to be geared towards this application? But the real question was, how can we use everyday materials? Because the plastics that we were using were exciting, but kind of a small subset of what might be possible in industry. And that really pushed us to develop a whole range of materials and work with a number of different partners in different industries. One of the first industries that came to us was the apparel and footwear industry. And they're obviously excited about making adaptable fit, adaptable structure, breathability for clothing and shoes, waterproofing, appearance change, performance change, all of those kind of things. The footwear industry has long desired robotic shoes, essentially, but the challenge there is that you don't want the cost of traditional robotic or smart materials, you don't want the excess of assembly required, and you don't want these failure-prone components that are traditionally found in robotic mechanisms. So what they really want is a simple material that can behave like a robot, but it's pure material, no robots required. We're working with Airbus in the aviation industry on a carbon fiber flap that transforms to cool the engine. We're working with a supercar company called Briggs Automotive on adaptive aerodynamics. So cars, planes, boats have always had shape-changing panels, but they've been excessive actuators and mechanical means of changing shape. And so we're proposing carbon fiber, simple materials that can transform on their own to change aerodynamics, change performance on the fly. We're also working with some people in furniture and building materials and medical devices. So really many industries that are interested in transformation on a material level. I think there's two categories of industrial applications. One is where traditional robotics are found today. So many industries use robotics from all sorts of different applications, and there's an interest to make them more streamlined, more material-based, less massive motors, metal, and electronics. And so there's like an elegance or an efficiency in lightweight, super adaptive, transformative materials as robots. The other category of applications for programmable materials is where static products, whether that's clothing, furniture, or buildings, any product that's today static could be dynamic, adaptive, reconfigurable, and I think materials that can change their shape or property is a nice way to do that. Our collaborations with industry have surprised us many times based on what they're interested in, what the challenges they face, or look at our technology in a totally new way. So we may be developing something like 4D printing and think it's really applicable in this one space, but the first industries to come to us maybe in a totally different sector, and they'll say, can we do it in sportswear? Can we do it in orthodontics? Can we do it, all these industries that we hadn't thought about, and they all bring new opportunities but also new challenges. They have different energy sources, they have different material requirements, different regulations, etc. And so it's exciting to try to develop the technologies for those industries.